Intel has been going through a challenging time recently, with reliability and power consumption issues with both the 14th and 13th gen processors. But if there's one thing I've learned in all my years working in the tech industry, it's to not count a company like Intel out. All companies have ups and downs, and Intel is no exception to this over its 56-year history. For instance, does anyone even care now how problematic Pentium 4 or Pentium Pro were? Now back to the present moment, and Intel is today unveiling a new range of Core Ultra 200 series desktop PC CPUs, codenamed Arrow Lake, and we thought we'd take a closer look. Now, names have meaning, and the fact that Intel has ditched its Core i naming system in use since 2009 says a lot about these new processors, which Intel is branding as Core Ultra. There are still 9, 7, 5 and 3 ranges, but these lack the letter I and are immediately followed by a new model numbering system. As an example, the new flagship processor is the Core Ultra 9 285K, compared to the old Core i naming system for the Core i9 1400K. Now let's take a look at what new tech Intel has come up with to justify the new naming system. Well, up until now, Core processors were built from a single die, but Core Ultra processors ditched this monolithic system in favour of a much more flexible multi-tile system comprising separate tiles for the CPU, GPU, I/O and SoC. This is quite a step change for Intel, and not only makes manufacturing simpler, but also enables Intel to produce models with different configurations far more easily. The first desktop Core Ultra CPUs, such as the aforementioned Core Ultra 285K, are not only made this way, but also include a whole host of new features and capabilities. Now, one of the greatest areas of innovation and development in the tech industry in recent years has of course been in artificial intelligence, and Core Ultra marks Intel's first foray at giving desktop PCs hardware-accelerated AI capabilities. This takes the form of a dedicated NPU, which stands for Neural Processing Unit, and this comprises one of the many elements of the SoC tile alongside the memory controller, security manager, primary PCIe bus and DMI bus. Combined with DL Boost instructions running on the CPU cores plus a new GPU, the NPU is capable of delivering up to 36 TOPS of AI performance. Now, to put that into perspective, that's approximately 3.5 times faster than a 14th gen Core CPU trying to do the same work using DL Boost alone, and just over double AMD's fastest NPU-equipped desktop CPUs, Ryzen 8000G, which are rated up to 16 TOPS. As the NPU is compatible with all major operating systems like Windows, Linux and Chrome, plus major frameworks, it already supports 100 plus AI-enhanced applications from the likes of ISVs such as Adobe, Blackmagic and Unreal Engine, to name just a few. However, despite supporting AI functions in Microsoft Office and Teams, 36 TOPS isn't quite enough performance to meet the 40 TOPS requirements for Copilot+. Core Ultra 200 series CPUs retain the same overall hybrid architecture, comprising a mixture of P and E cores, first introduced in 12th gen Alder Lake core CPUs. Now is a good time for a quick recap. P or performance cores are designed for intensive applications, whilst E or efficient cores are designed for background tasks. However, the cores themselves are all new, with the P cores going under the codename Lion Cove and the E cores Skymont. Intel claims these new cores deliver a 9 and 32% respective IPC improvements over 14th gen Raptor Lake refresh. Key improvements in the Lion Cove P cores include increasing the level 2 cache from 2 to 3 megabytes per core, plus tweaks to the scheduler and out-of-order engine. The Skymont E cores have increased level 2 cache bandwidth, enhanced prediction, deep queuing and wider allocation and retire. Now, it is worth noting, however, that after more than 20 years service, Intel has removed hyperthreading from Core Ultra CPUs, so each core can only process one thread at a time. Now, we can only speculate that Intel thinks it's found a more efficient way to speed up multi-threaded applications or when multitasking. Outside of the cores themselves, there's also support for more and faster RAM, up from 192 gigabytes of 5,600 megahertz DDR to 256 gigabytes of 6,400 megahertz DDR5. The I/O has also been upgraded, adding another 4 PCIe 5 lanes, bringing the usable total up to 20, plus 4 PCIe 4 lanes. Intel has also added in native support for USB 4 and Thunderbolt 4, whilst laying the groundwork for Thunderbolt 5 via a discrete chip on the motherboard or a PCIe add-in card. These are substantial upgrades to the I/O, making Core Ultra much more forward-looking than Core systems. Now, all of these enhancements go hand in hand with a new range of 800 series motherboard chipsets. The first of these, the Z890, has more PCIe lanes than its immediate predecessor, the Z790, which is how Intel has managed to squeeze in 2 USB 4 Thunderbolt 4 ports on top of the existing USB 2 and USB 3 ports. And as you'd expect, there'll be other 800 series coming down the line with lower specs too, but these are under NDA for now. Now, speaking of motherboards, you can expect Z890 motherboards from all the usual suspects such as Asus, MSI and Gigabyte. Despite Core Ultra CPUs using a new LGA 1851 socket, this has the same external dimensions as LGA 1700, so most CPU coolers should be compatible. Intel has finally ditched the aging UHD Graphics 770 integrated GPU in favour of a far more modern and capable Xe LPG GPU. And this not only boasts double the number of execution units, up from 32 to 64, but also support for DirectX 12 Ultimate and all its goodness, such as ray tracing, mesh shading, VRS Tier 2 and sampler feedback. The display outputs have also been upgraded to HDMI 2.1 and DisplayPort 2.1 UHB R20, enabling support for higher resolutions and refresh rates. Now, of course, we doubt many consumers will ever make much use of the integrated GPU, but it's good to see Intel upgrading and updating its capabilities for corporate customers. Plus, the new GPU does contribute 9 TOPS of the 36 total TOPS performance of Core Ultra. So now we've covered the key improvements and additions, let's take a look at the lineup of CPUs Intel is announcing today. This includes 3 main models, an Ultra 9, an Ultra 7 and an Ultra 5, plus variants of the 7 and 5 without integrated graphics. The latter can be easily identified by the addition of an F at the end of the model number. The flagship Core Ultra 9 285K is equipped with 8 P-cores and 16 E-cores, giving it a total of 24 threads now that hyperthreading has been dropped. This is less cores than its immediate predecessor, the Core i9 14900K, but the architectural improvements should make up for this. And it's a similar story with the Core Ultra 7 265K, which has 8 P-cores and 12 E-cores, and again with the Core Ultra 5 245K, which has 6 P-cores and 8 E-cores. What's not apparent though from the table, despite all the CPUs having 125 watt TDP, is how much more power efficient Core Ultra is than Core. And whilst we can't share our own test results just yet, Intel claims between 42 and 58% lower power consumption in lightly threaded workloads. Unfortunately, although I'd love to tell you in detail about the benchmarking the tech wizards in our 3XS systems have done, such as the Core Ultra 200 series being 20% faster than 14th Gen Core and 20% faster than AMD Ryzen 9000 series, full results for the new Core Ultra CPUs are still under wraps for now. However, Intel's official pre-release benchmarks are claiming up to a 19% speed up over 14th Gen Core and up to 7% over Ryzen 9000 series. We expect to be able to publish full benchmarks in a few weeks' time. In the meantime, let us know in the comments below what you think of Intel's new Core Ultra 200 series CPUs, especially the new AI capabilities and lowered power consumption. Then follow the links in the description below to the SCAN website, where you can find out more about Intel Core Ultra and preview our next-gen 3XS systems.